Hey students, welcome back. This is Unit 6. We are going to start gas laws, the gas laws unit. Remember to put your header across the top, 6-1, pressure, page 35. And we are going to start by talking about some properties of gases. So, first off, the first property a gas can have is that it can be compressed. Can be compressed. And what that means is that we can squish it down into a smaller area, right? We can compress a gas into a smaller area. Think of a balloon. We can squeeze a balloon and the balloon can be squeezed, all right? We can't really do that with liquids and solids, right? They won't squeeze down into smaller areas. All right, our second one is that gases exert pressure. All right, our gases exert pressure. And pressure is force per unit area. And we'll actually talk a little bit more about that right down there, as you can see. The pressure depends on how much you have. So how much gas we have. All right. That's our third one. Our fourth one is that gases will completely fill a container. This is also, all of these are making them, this is what distinguishes them from other types of matter. Right? So, we're talking about completely fill a container. Like if we put a gas into a room, it's going to spread out to the whole entire room. It won't just stay in one small corner, where a liquid would probably stay in its own little spot, or a solid, that's not going to fill the container. All right. Gases also mix freely and combine easily. Just like as it fills the room, it's going to mix with other gases, right? And you won't just have the oxygen all hanging out in one corner and the helium hanging out in the other corner. They're all going to mix together. And then the last one is that as the pressure rises, as pressure goes up, the temperature goes up. That's actually one of our gas laws, but we'll discuss that a little bit later, probably next week. Okay, so those are distinguishable for gases. Those are items or properties of gases that kind of set them apart from the other ones. Okay, so let's talk briefly about pressure. Pressure, as we said before, is force per unit area. And what's happening here is that the gases, let's say the gas particles, are colliding with other things in the walls of the container. All right. And that's actually where the pressure comes from, where we have the walls of the container. All right. Now, next up, we have how we measure pressure. There are two different ways to measure pressure. The first one is probably one maybe that you've heard of, and that is our barometer. All right. Our barometer measures atmospheric pressure. All right. Atmospheric pressure. And this is what, like, the weather people are talking about when they're talking about like barometric pressure. They're measuring the pressure of the atmosphere, and that'll actually affect how our weather is looking to us. Okay. Then we have a manometer, and a manometer just measures pressure. This is what we would use in the lab if we were going to measure pressure in the lab. All right, a manometer. Okay. Now let's talk about how to convert our units of pressure. Okay, so real quickly, the units of pressure, and this is not an all-inclusive list. It's actually, there's a lot more, but we're just going with the ones that we know right now, all right? Or the ones that we need to know, not the ones we know right now. I know there are others. You probably know of others. All right, so this little list, is something you need to know. And actually, if you have your periodic table handy, you can check out the back of that. On the back side, very near the bottom, in the bottom 1/3, it says pressure units, and all of these are on there with the exception of the 760 torr. All right, we didn't put the 760 torr on there because torr and mmHg are the same thing. All right, so that one, if you want to add it on, you can, or just remember it's equal to mmHg. So what we're going to do is we're just going to do some conversions from one unit to another using our T-charts like we've been doing for quite some time, well, since first semester. So if we look here, I'll try to keep that somewhat there. So we have 730 mmHg and we're going to PSI. So of course I blew it up too much and we can't even see PSI, but we see that 14.7 PSI equals 760 mmHg. So just continuing to practice our unit canceling, we have not 14.7, Griffith. Ooh, let's try that again. All right, how about 730 mmHg? Right? Because that's what's given to us in the problem. Boop, that came from right there. All right. We're going to put, just like we did on our multiple ratio, we're going to put where we're going on top and where we've been on bottom. So we're going to put 14.7 PSI because that's what we're looking for. On bottom, we're going to put where we've been, which is mmHg. All right. And if we look, mmHg cancels. All right, and now we're ready to calculate. So to calculate this, just a quick reminder, a quick refresher, we're going to take 730 times 14.7 and then divide it by 760, and that'll give us our answer. All right, 730 times 14.7 and then divide that by 760. We're going to get 14.12, and let's go ahead and keep 2 decimals in our answers. Just continue practicing that so we don't change the rules midway. So 14.12 PSI. All right, awesome. Let's work that next one. Okay, this time we're going from bar to torr. We know that if we want to write our equivalence statement here, we know that 1.01325 bars equals 760 torr. All right. So, starting on our little T-chart, 0.888 bar, right? We're going to put 1.01325 bar on bottom. On top, we're going to put 760 torr. And we really should be capitalizing torr because it's named after a man, but we'll be okay. So we'll take 0.888 times 760 and then divide by 1.01325. And our answer should be 666.05 torr. All right, there we are. All right, this last one I want you to kind of try on your own. I'll give you a little chance and I will slowly work it out. Okay, we're going from kPa to ATM. kPa to ATM. All right. You know, just kind of getting you started, 101.325 kPa is equal to 1 ATM. So on your T-chart, you're going to start with 98.3 kPa. So we'll put 101.325 kPa on bottom and 1 ATM on top. kPa's will cancel, and you're ready to do your math. And our answer there, 0.97 ATM. All right, guys. See you next time.